All right, we're going to start at question number 35. Let R be the triangular region in the first quadrant with vertices at 0, 0, A, 0, 0, B, where A and B are positive constants. I'm going to graph this. So 0, 0, A, 0, A is positive, somewhere here on the right is A, and up here somewhere here is B. And there's a triangular region that they're talking about. Then it says, which of the following gives the volume of the solid generated when the region is revolved about the x-axis? Well, if we revolve about the x-axis, I know the template. It's going to be pi r squared. It's a circle. And when it's revolved around the x-axis, it's dx. And when I look at each one has the right template. So then what goes inside here if I'm revolving it around the x-axis? And we're going to go top, subtract bottom. So it's this region here. So the top is that line that connects B to A. And the bottom is 0. So we don't need to go top, subtract bottom because the bottom is 0. So I just need an equation for that line. So an equation for that line, the slope of it is down B and to the right A. So the slope is down whatever the B is and to the right A. That's the slope. And then the y-intercept is B. So that's mx plus b, and then if you look at the answer choices, that matches with D. Number 36. What is the volume of the solid generated when the region in the first quadrant is bounded by the graph y equals 2x, the x-axis, and the vertical line? Let's see if I can get this focused in here. Maybe if I get just a little closer, it'll focus in. But let's try. All right. Sometimes I have issues with the focus of this camera that I'd like to have, like, in terms of what's happening. So again, it keeps kind of going in and out, and it's trying to focus, is it? And that kind of thing. So let me see if I can make it work here. Makes it challenging for me to get through this video, obviously. Try to get closer and then try to pull away, see if it will actually do what it needs to do. So I feel a little bit. Alright. Maybe. Alright, I think maybe. We're going to see. Looks like it's focused now. So I'm going to draw the line 2x. I don't need it, only in the first quadrant. The vertical line x equals 3. And it's being revolved around so it's this area here. And it's being revolved around the x-axis. So revolved around the x-axis is a circle. So it's pi r squared. Top subtract bottom is just that line. So it's 2x represents that radius. And that's it. Now we need to be able to do the work. Oh, the bounds go from 0 to 3. So this is 4x squared. I'm going to integrate it. So add 1 to the exponent and divide. And again, we're integrating from 0 to 3. And then after you integrate it, plug in the upper bound. Subtract the lower bounds. When I evaluate at 0, the answer is 0. And this is 27 divided by 3. That's 9 times 4, so that gives me 36 pi. So the answer matches with B. 37. So the temperature in a room at midnight is 20 degrees. Over the next 24 hours, the temperature changes at a rate modeled by that differential equation h at t, Celsius per hour, and measured in hours since midnight. And it says, which of the following is the best interpretation of what you see here? So we're at midnight. So from 0 to 6 is midnight to 6 a.m. Now the second part is understanding the temperature changes from there to there. So the change in temperature is what we're looking for. So when I integrate it from 0 to 6, what change in temperature has happened from midnight to 6 a.m.? That's what I'm looking at. And so the answer is C. Number 38, a particle moves along the x-axis so that at any time t is greater than or equal to 0, its velocity is given by that equation. So it's v at t equals sine 2t. If the position of the particle of time t equals pi over 2 is x equals 4, what's the particle's position? And we're just going to break it down one part at a time. I got a new camera and I thought, man, this is going to make life so much easier. Having a new camera that I can zoom out a little bit at so you can see the whole question at once. And it hasn't been that way. I wish this was the case, that we could do that. All right. So what do we have to begin with? We have the velocity, so let's write it down. And then it says our goal is to find the position. So I know I need to integrate this. So to integrate this, the hook comes from inside the parentheses. So the derivative of 2t is 2, which means it needs a 1/2 in front so that I can integrate it. So I'm going to circle and undo that hook. Now I need to know the antiderivative rule for sine, and that's negative cosine. So I'm going to write down negative cosine with a 1/2 in front. And of course I need a plus c, and that's the position equation. So integrating velocity gives you position. Next, it gives you a value. So when t is pi over 2, x is equal to 4. So it moves along the x-axis. So x equals 4 is the answer part. T is pi over 2, and then I need to solve this for c. So the 2's divide out. The value of cosine at pi is -1, so it's -1/2 times -1 plus c. So I'm going to solve this. So a negative times a negative is +1/2, but when I subtract it, it becomes 3.5 on the other side. So now my equation is this: -1/2 cosine 2t, and then my constant is 3.5. Now it says, what do you do with that? So using that, what is the position at 0? You plug 0 in and solve it. So plug in 0 for t. 2 times 0 is 0. So what's the value of cosine at the angle 0? And the answer is 1. So it's 1 times -1/2. So it becomes -1/2 plus 3.5. So combine that together and it's just 3. So the answer is C. Number 39. The velocity of a particle moving along the x-axis is given by a velocity there. And the particle is at x equals 4 when t equals 1. It says, what is the position? So again, I need to integrate it. Now I just integrated this, so I don't feel like doing it like all over again. Well, do I have something on my shirt? So I don't think you even saw that, but I got it. We just did it. So the position then is -1/2 cosine 2t. And if you want to look, go back to the last question and see how I got it. And then it says the position of the particle is 4 when t is 0. So I need to solve for the constant. So cosine at 0 is 1, so it's negative a half, so I'm going to add it to the other side. So now the constant is 4.5. So now I'm going to rewrite the equation. So there's the equation, and it says what's the position when t equals pi over 2. So then I'm going to use that equation, and I'm going to plug in pi over 2. So I need to know my unit circle just a little bit. So the 2's do divide out. The value of cosine at pi is negative 1. So it's a negative times a negative, so it's positive 1/2 plus 4.5. So the answer to that is 5, and that matches with D. All right, turn the page. Number 40. For time t is greater than or equal to 0, the position of a particle traveling along a line is given by a differential function s. If s is increasing from 0 to 2 and is decreasing after 2, which of the following is the total distance the particle travels? And the key word in this whole question is the word total distance. So if you know the velocity, the total distance is the absolute value of velocity. That's what it equals. And you need to know that velocity is the derivative of the position. So if I put this together, this is what I'm looking for. The absolute value of the derivative of the position from 0 to 5. And so there's the answer there that matches it. 41. In question number 41, you're given a graph that's a velocity graph from 0 to 8. Of the following, which is the best estimate of the distance traveled by the car from 0 to when the car comes to a stop? So from 0 to 8, this is the rate the car was going. So how do I take that rate graph and find the distance the car traveled? And the answer is I need to find the area under the curve. And how would I estimate it? And honestly, I think the best way to estimate this is to take the rectangle and divide it in half. It's not perfect. So if I take the rectangle, it's 50 by 8, that's 400, and then divide it by 2. That gives me an approximate answer of 200. If I look really carefully, it's actually an underestimate. It's not quite half. It's a little more than half if you look at the curve of it. So I'm looking at an answer very close to 200, but it's a little bit more. So that's why the answer is D. There wasn't any obvious geometric shapes. You can make rectangles and triangles and kind of estimate, but I think in this situation, take the whole rectangle, divide it in half, and that gives you a good answer. Number 42. In number 42, a particle moves along the x-axis. The velocity of the particle is 6t subtract t squared. So I'm going to write that down. That's the velocity. It says, what is the total distance? So from 0 to 3, the total distance is found by integrating. And we're going to integrate from 0 to 3. And it's the absolute value of 6t subtract t squared. Now, I'm not going to integrate in terms of absolute value, but this is what I am going to do. Is I want to know from 0 to 3, are the values always positive, or are there some negative values in there? So if I plug in 0 for t, it's 0. If I plug in positive 1, it's positive. Positive 2 is positive. Positive 3 is positive. All the values from 0 to 3 are positive. So the bars are unnecessary because all the answers are positive. So I can just integrate without the bars. And then how do I integrate this? So we're going to add 1 to the exponent and then divide. So 6 divided by 2 is 3. We're going to add 1 to the exponent and divide, and then we're integrating from 0 to 3. We're going to evaluate using the upper bounds. We're going to plug the upper bound into the function. And then we're going to subtract and plug in the lower bound. Well, when I plug in 0, the answer is 0. So that's not going to affect my answer. So this is what I'm evaluating. So this is 27, subtract. Now 27 divided by 3, that's 9. So 27 take away 9. So the answer is 18. And that answer is D. Number 40. No, we did 40. Number 43. So there's 18 right there. So number 43. There we are. A particle travels along a straight line with a velocity that's given. Notice we're going to use a calculator here. What is the total distance in meters traveled by the particle? Now, the key word here again is total distance. And so I know total distance is the absolute value of velocity. So that's what I'm focused in on. So I'm going to integrate from 0 to 2. And it's the absolute value. And then you put in the velocity, which is 3e to the negative t divided by 2 sine 2t I'm going to let you put that in the calculator. So know where the absolute value button is on our calculator. So when I have our calculator, press the button to the right of 9, and what you see here, there's the integration. Notice the bars up here on the left. So just move and highlight, press enter for the absolute value. Anyways, type it all in, and if you did it correctly, the answer is 2.261. Number 44, another calculator question. So I'm going to set it up, and then you can type it in the calculator. A particle moves along a line, so its acceleration is given there. If the particle's velocity at t equals 0 is 5, what's the velocity of the particle at t equals 3? So this is a beginning value or a starting value question. So the velocity starts at a value of 5, and then the acceleration, when I integrate it, will tell me if the velocity is increased or decreased from that. So from 0 to 5, take the acceleration, type that in, and you get the answer 11.710. So practice typing that in. Make sure you know where your buttons are in your calculator. If you go control and the divide sign, you could get a fraction. Type it in. Know where the radical button is. Just take your time typing all this in and make sure you get the right answer. Number 45. This one's a really challenging one, so I'm just going to directly tell you the answer. But a city is built around a lake. So you have a lake, and then a city is built around that lake. The lake has a radius of 1 mile. And then it says that people live within a mile of the lake here, around the lake. And it says the density here is represented by F at R. And in one sense, you could think of this as the radius, the circumference times the density. So the circumference is 2 pi r, and the density is F at R. So if we multiply that together and we integrate, now if you see, people aren't living from 0 to 1 is the lake. So if this was like on a graph, from 0 to 1 is the lake. So we need to integrate from 1 to 2. So if I look to see which one matches that up, that is D. Number 46. In number 46, you're given a table of values of the velocity. So beginning velocity is -1, then 2, 3, 0, and then back to negative. And say which one could be the position. Well, if you work backwards, understanding position graph, if velocity is negative, the position is decreasing. if velocity is positive, the particle is increasing, and then back to decreasing again. So at the beginning it's decreasing, and then increasing, and then decreasing. So that's what I'm looking for. So this is not matching. And so I'm just going to go until I find the one that matches. Decreases, increases, decreases. So B is not. It has to be falling to begin with. C, notice how it decreases, increases, and then decreases. This one matches. And notice at 1, we have a positive value at 1 for the slope. If I turn the page, the reason, well, D is wrong because it needs to be decreasing, then increasing, then decreasing. Now this one is right. This is decreasing, increasing, and then decreasing. So that matches, but this does not match. At 1, the slope is negative. It's decreasing at 1. And when I look at the table of values, at 1, we have a positive value at 1. So the one that matches and at 1 is positive, at 2 is positive, at 3 is 0. So that means at 3 there's a turning point. Let me see, is there even a turning point at 3 here? Well, there is. All right. And then it decreases. So 1 is really the indicator. So at 1 we have it's increasing, a positive slope. When we turn the other way, it doesn't match. So the correct answer here is C. 47. In 47, let R be the region in the first quadrant, bounded above by the graph y equals 7/3 x plus 1, and bounded below by the graph y equals 2x. From 0 to 3, which of the following definite integrals gives the area of the region correctly? So to begin with, maybe it's nice to have a little graph of it. So y equals 7/3 x plus 1 starts at 1, it goes up 1 and to the right 7, so it's increasing here, something like this. Y equals 2x also is 1, and it kind of curves and goes up. That's probably too much of a curve, but you need to see which one's above and which one's below. So the line is above and the curve of 2x is below. I need to know from 0 to 3, that's what we have. Top subtract bottom, that's correct, so this one is a true statement to find that area. Another way to find this area is to go right subtract left. If that's true, I need to solve for x here. So to solve for x, I'm going to subtract 1 and then multiply times the reciprocal. And for the second one, I also need to solve for x. So that's going to be ln, or log I should say, with a base of 2 and then y. So I'm writing this as a logarithm where the base is 2. And another way to write this is to change the base to ln y divided by ln 2. Now, if I go right subtract left, the curve should come first. So this should come first and then subtract this. So look at ln y divided by 2, subtract, and that line comes second. So it's right subtract left. And then the next thing is notice the bounds. The bounds now would be the y values. So this is positive 1. This value here, when you plug in 3, the answer is 8. So it goes from 1 to 8, and that's where that comes from. So this one's also true, that one's false. So that matches with D. Number 48. What is the area of the region in the first quadrant bounded on the left by the graph y squared divided by 2, and on the right by the graph x equals 3y subtract 4? And we are going from 2 to 4. All right. So it'd be a couple things would be helpful here. First of all, I'm going to make them equal to each other. I'm going to multiply everything times 2. I kind of want to know where the upper and lower bounds are. Oh, it even gives it to me. So why am I doing that? It's from 2 to 4. And if you'd answer, it'd be 2, 4. So first of all, I'm going to integrate from 2 to 4. Next, I need an understanding of the graphs to know which one's on the right and which one is on the left. It even tells me that. So on the left is this, and on the right is the line. So that means I put 3y subtract 4 first. It's right subtract left. And then subtract the left, which is y squared divided by 2. So that's nice that it got explained to you. Right subtract left. And now I'm going to integrate this. So 3y would be 3y squared divided by 2. Negative 4 would be negative 4y. And then y squared would be y cubed. When you divide by 3, 2 times 3 is 6. And I'm integrating from 2 to 4. Now, without a calculator, this might be a challenge, but I want to see if you can meet the challenge. So substitute 4 in. Subtract. Now plug in 2. So first substitute in 4, then plug in 2. All right, I want you to press pause and try to get the answer. Honestly, without a calculator. Simplify it, do your best, do the work involved, like working out at a gym a bit here. Get that brain going, see if you can evaluate it. I'll see if you did it right. So press play now, and then see if it matches. So if you combine the whole numbers, you get 10. If you combine the fractions that are over 6, so that's this one and this one, you get 56 over 6, and the answer is A. I wonder if you got the right answer. 49. Let f be that function, sine 2x times cosine 1 plus x. What is the average value of the function? To find average value, it's an integration question. So we're going to integrate from 1 to 3. And we integrate the function. And then we divide by the difference of the bounds. So you need to type this in the calculator. And you can just go divide it by 2 and then see what answer you get. So press pause, do the work, and then press play. Let's see if you got it right. 50. In question number 50, the average value of a function from negative 2 to 3. So if I integrate from negative 2 to 3, some function, and then you would subtract the difference of the bounds. So 3 subtract negative 2 is actually 5. If you did that, the answer is negative 6. The second part says the average value of the function from 3 to 5. And again, divide by the difference of the bounds is 2, is 20. And then the question is, what is the average value of the function from negative 2 to 5? So I know I'm going to do that. So when I subtract these, I get 7. So now the question is, how am I going to find that? Integrating from negative 2 to 5. It doesn't give me that answer directly. So what I'm going to do is I'm going to multiply both sides by 5. By multiplying times 5, I get the integration by itself. So when I integrate from negative 2 to 3, the answer is 30. I'm going to multiply both sides here by 2. So when I integrate from 3 to 5, the answer is 40. My question is, what happens when you integrate from negative 2 all the way to 5? So since I have the answer to 3, and I have the answer from 3 to 5, all I need to do is add these up, and that will tell me the area under the curve from negative 2 all the way to 5. So negative 30 plus 40 is 10. So that means from negative 2 to 5, the integration or the area under the curve is 10, and you divide that by 7, the difference of the bounds, and you have your answer. Number 51, a calculator question again. For time t is greater than or equal to 0, the velocity of the particle moving along the x-axis is given by that velocity. The initial position of the particle at time t equals 0 is 0.085. What is the displacement? Now the word displacement from 0 to 5, there's a lot of unnecessary information. Displacement means you're going to integrate, and we're going to integrate from 0 to 5. And you're just going to integrate the velocity. If you're asked for total distance, it would be the absolute value. But displacement, it's just the velocity. So I want you to put that in the calculator. Integrate from 0 to 5, arctangent t squared plus t subtract 1. And you should get the answer. Well, press pause. Do the work. Now press play. You get 5.504. All right, number 52. The acceleration of a particle is given. And you're talking about the velocity and the position. So we need to work backwards here by integrating. So first I'm going to find the velocity by integrating this. So the integration of cosine is sine, and the integration of t is you add 1 to the exponent and divide by that exponent plus c. It says the velocity is 8 when you plug in 0 for t. Well, sine 0 is 0, and 0 divided by 2 is 0. So the initial velocity is what c is. So c is 8. I'm going to integrate to find the position. So the integration of sine t is negative cosine t. The integration of t squared would be t cubed divided by 3. That's 6. 8 would be 8t, and then the constant. And again it says the position of the particle at time 0 is 0. So when I make it equal to 0, the only challenge is here, the value of cosine at 0 is 1. So this is negative 1. Everything else is 0 plus c. So to get c by itself, add 1. And really because we have another you would have to rename it, but it's fine. The constant is 1. So this is the position. And then it says, what's the position of the particle at pi over 4? So now you plug in pi over 4 and get your answer. Now, the value of cosine at pi over 4 is root 2 over 2. So it would be negative root 2 over 2. This is pi cubed. And that's 64 times 6. If you turn the page, you'd see that that answer is 384. But there's only one answer choice that really comes close to matching it. So that's what it looks like when you simplify it. Again, this is a bit of a mess, but if you look at the answer choices, that part is, there's only one answer choice that's similar to that, so the answer is C. (53) You're given a graph. It says the figure above shows cosine and the line y equals 1. And it says which of the following gives the sum of the areas of the region. We need to know its top subtract bottom. So the first one is 1, subtract the cosine. The next one is cosine, subtract 1. And then the last one's the line, subtract cosine. So we got to keep that in mind. And then it says we need to know that it goes from negative pi over 2 to negative pi over 3. And then negative pi over 3 to positive pi over 3. And then pi over 3 to pi over 2. So which one is the correct one that goes top, subtract, bottom as you go along? And so that's going to match with C. So first we go negative pi over 2 to negative pi over 3. The line subtract the curve, then negative pi over 3 to positive pi over 3, the curve, subtract the line, pi over 3 to pi over 2, the line, subtract the curve. So it's the correct top, subtract bottom with the correct bounds. Number 54. So the absolute value of sine there is given. That's this thing that kind of looks like the McDonald's, looks like M. And then the parabola is in the middle. And it says where they intersect is one is x1 and then the other one is x2. And it says what's the correct setup to find the area. So it's always top, subtract bottom. So first it's the absolute value, subtract the parabola. Then it's the parabola, subtract the absolute value, and then the absolute value, subtract the parabola, and then the bounds, negative 2 to x1, x1 to x2, and x2 to 2. Which one is the correct setup that did that? And the answer is D. It's a long one, right there. It has to show 3 different integrations there properly. So each one, the bounds are correct, and top, subtract bottom is correct. 55. Let R be the region in the first quadrant bounded by the graph y equals tangent x. The x-axis and the vertical line x equals 1. Which of the following gives the volume of the solid generated when the region R is revolved around the x-axis? Okay, we're going to graph this. So tangent starts in the middle and then curves up to the right. X equals 1 is somewhere here. And this is the area that we're revolving about the vertical line, x equals 1. So you're taking this area, revolving around x equals 1. So when we revolve around a vertical line, it needs to be in terms of y. So I need, instead of y equals tangent x, I need to solve for x. So to get x by itself, it's the inverse. So that's what x equals. And it's right, subtract left. So on the right is 1, and then you subtract arctangent. So that's the right, subtract left. And then the upper and lower bounds. So the bounds go from 0, and then I have to find this bound right here. So the x value is 1. So when I plug it in here, it would just be tangent 1. It's not on the unit circle. That we know, the obvious thing. So the bound goes from 0 to tangent 1. And again, we're revolving, so it's pi r squared with respect to y. So that matches with A. 56. What's the volume of the solid generated when the region bounded by that graph, y equals x cubed, the vertical line x equals 4, and the line y equals 8 is revolved around the horizontal line y equals 8. All right. So here's x cubed. Here's y equals 8. So that point there is 2, 8 because of y equals x cubed. So the region is bounded by y equals x cubed. The vertical line x equals 4. There's 2, 3, 4. And the horizontal line y equals 8. All right. And we're revolving it around that line. So let me redraw this. What am I doing wrong? So we have y equals 8. We have x equals 4. At 2, the answer is 8. So we have y equals x cubed, the vertical line 4, we have y equals 8, and it's revolving around that. So we have it from 2 to 8, 2 to 4. Let me look at that. So I know that's revolving, so we have this around a horizontal line. Oh, here. If I take y equals x cubed and y equals 8, they intersect and they tell me that value that I need. So cube root it and you get 2. So that's where 2 comes, where it's 2 to 4. And then it's top subtract bottom. So in this case, I know I drew this all wrong. So if you go top subtract bottom in terms of revolving it, it would be x cubed subtract 8, right? Squared. So there's your answer. 57. All right, moving on. So in 57, let R be the region bounded by that graph. So the top is 1 subtract x squared. The bottom is x squared subtract 1. So 2 parabolas. So these are going to be my bounds. So what's the volume of the solid generated when that region is revolved around y equals 3, which is somewhere up here? So there's a space between this region and the line that I'm revolving around. So it has to be what's called the washer method. So we have 2 radii. So the setup first of all is going to be -1 to 1. And you have the big radius subtract the small radius. So there's the setup. Now the big radius, you take the line that you're revolving from and go all the way through the area to the bottom. So it's going to be 3 subtract this bottom one. So we're going to do that. 3 subtract, the bottom is 1 minus, or x squared minus 1. And then the smaller radius is this radius right here. So that's the 3 subtract the parabola that's concave down. And that's what we need to solve. So now it's a matter of some algebra, some calculus, and be able to get the answer at the end. So let's help us through that. So first of all, I'm going to simplify this. So 3 subtract -1 is 4 subtract x squared squared. 3 subtract 1 is 2, and it's subtract a negative plus x squared. I'm going to FOIL inside. So 4 subtract x squared squared, I need to have the ability to expand it. That's 16 minus for 8x squared plus x to the fourth. I'm going to do the same thing here. That's 4 plus 4x squared plus x to the fourth, expanding it. I'm going to combine like terms, and eventually it's going to get easier. So 16 subtract 4 is 12. Negative 8x squared subtract 4x squared is minus 12x squared. And x to the fourth subtract x to the fourth, it's now eliminated. So that's all I'm left with. So integrate it. That's 12x. Add 1 to the exponent. 12 divided by 3 is 4. And I'm integrating from negative 1 to 1. So now you're going to plug in 1. That's 12, take away 4. That's 8. Then you're going to plug in negative 1. That's negative 12. Now a negative times a negative is positive. So it's negative 8, but a negative and a negative is positive. So altogether that's 16 pi. Number 58. Let M be the region in the first quadrant and you're given the graph y equals 2 over pi x and the graph sine x. And then which of the following gives the volume generated revolving about a vertical line? When you revolve around a vertical line, it needs to be in terms of y. So I need to get x by itself. So x is equal to arc sine y. And here, to get x by itself, do the reciprocal. To both sides, it's pi over 2y. I need to make them equal to each other. And think, what value of y would make them the same? And the answer is, to solve it, if y is 1, arc sine of 1 is the angle pi over 2, and pi over 2 times 1 is pi. Like, 1 solves this equation. So that becomes essential for our bounds. So I'm going to turn the page. So I know I'm going from 0 to 1. If I have a graph, that's the graph of sine. The graph of the line looks like this. And this is the region I'm doing. And I'm revolving it around the line negative 3. So I need to go right, subtract left. There's a space. It's going to be the washer method. And when I go right, subtract left, on the right is the line, pi over 2y. And when I subtract negative 3, and then the curve, the invert, in terms of y, would be arc sine y. And again, I need to subtract negative 3. And now look at the answer choices, the ones that would match it. And so that matches with D. 59, calculator question. It says, find that area. And again, it's around a vertical line. So when it's around a vertical line, I have to change these. So it says x equals. So to get this by itself, I actually do tangent undoes arctangent. And the second one, you do the reciprocal to get x by itself, 4 over pi. Again, if you made them equal to each other, you could use your calculator to solve it because you have a calculator, so you can do that. Or you could recognize the answer is pi over 4. because the value of tangent at pi over 4 is 1. 4 over pi times pi over 4, the answer is 1. And so we're integrating. It's a circle. It's a washer. And we're going to go from 0 to 1. And it's right subtract left. So on the right is the line. Oh, it's revolving around line 2. Sorry, so 2 is here on the right. So when I go right subtract left, it's going to be the curve first. So it's 2 subtract tangent y. And then 2 subtract the line, which is 4 over pi y. This is what you type in the calculator. So try typing it in, and you get this answer. And the answer is D. Number 60. A tank has 81.637 gallons of water. For the next 6 minutes, the rate it flows out. So we're subtracting for the next 6 minutes at that rate. And then how much is in the tank at the end? Put it in your calculator and you get 36.606. '61. It says this is the velocity of a bug crawling around. It says what's the total distance? Total distance is taking the absolute value of the velocity. So this area, all of this area, as a positive area and add it up. So the trapezoid is 1/2. So when you integrate from 0 to 8, that gives you total distance. Integrating off a graph means find the area. The trapezoid, the distance between the bases, that's 3. The one base is 2, the other base is 6. And then the triangle, half the base times the height. And again, we're going to write it as a positive area. And then if you did that work, the answer is 13. Number 62. At time t equals 0, the population is 1,500. It says the deer is increasing at this rate. So at time equals 3, what would how many deer would there be? So there's the setup. You start, use the rate from 0 to 3, and it gives you the total number. Round to a whole number. Use this when you plug it into the calculator, and you get 10,141. '63. The base of a solid in the first quadrant is the inverse of tangent. You have a horizontal line at 3, a vertical line at 1, and you have the graph, and you have this region. So this is the graph of arctangent, and then it's perpendicular to the x-axis, and it's a square. So we need to know our bounds. So it goes from the x value to the x value. So that's 0 to 1. And then the formula for a square is you take the base and square it. So the base is top subtract bottom. So it's 3 subtract the inverse of tangent. That's that curve underneath. And that's it. Put that in your calculator and you get the answer 6.612. 64. You have a graph 2x subtract x squared. If you graphed it, we have intercepts at 0 and 2, and it's a parabola that's folding down. This is the area here. And it says it's perpendicular to the x in an equilateral triangle. The formula for an equilateral triangle is that, if you know the base of the triangle, our base is top subtract bottom. So we're going to integrate from 0 to 2. root 3 over 4, and the base is simply the parabola. If you put that in your calculator, press pause, try it, and the answer is 0.462, and that answer is D. This is a repeat, so there's one question left. All right. No, that's not the repeat. I thought there was a repeat question in here. It's coming up. Oh, 67 is the repeat question. All right, here we go. So the graph x squared plus 1 line y equals 5 only in the first quadrant. And that's being revolved around the y-axis. So I need to know that x is equal to y subtract 1, and you take the square root. I'm integrating from, this is 1, and it goes up to 5. And it's the square root of y minus 1, and we square it. So it's pi r squared, and that's what you would solve. So square root and square undo each other. You have y minus 1. Integrate y minus 1, so add 1 to the exponent and divide. Negative 1 is negative y. And then substitute in. And if you simplify it, you get the answer 8 pi, believe it or not. Number 66. The region in the first quadrant is bounded by secant x. That starts at 1, that's a parabola, and pi over 4. And so it's this area here. And it's rotated around the x-axis. So it goes from 0 to pi over 4. Secant, and you square it. Pi r squared. Secant squared is actually a trig formula. It's tangent. Plug in pi over 4, that answer is 1. Plug in 0, the answer is 0, so the answer is just pi. That matches with C. All right. 67 is a repeat. So 68 is the last one with the calculator. The volume generated. So I think it's easier here if we square both sides and then add 2 so you know what the graph looks like. So if you square and add 2, you go to 2 and it's a parabola. And a line at y equals 5. And you're revolving this around the y-axis. So we're going from 2 to 5. And it's the square root of y subtract 2 squared dy. So it's pi r squared from 2 to 5. That's what you put in the calculator. So again, pi 2 to 5 square root of y minus 2 squared dy. That's what you put in the calculator. Press pause, and the answer is 14.137. That's it. Mr. G Math over and out. I'm proud of you for doing your work with me. I'm under an hour.